Alright, so we have to use what we know about special right triangles and degree radian conversion to find the exact value of these ratios. So first, let's convert these angles to degrees. So pi radians is equal to 180 degrees. So that to convert something from degrees to radians, we're going to multiply by pi over 180. Just like since 12 inches is equal to 1 foot, and I wanted to convert 3 feet to inches, I would multiply it by 12 inches over 1 foot, because those are equal, so it's like multiplying by 1, and now we get 36 inches. It's the same idea. Since these are equal to each other, just like these are equal to each other, we can multiply by like pi over 180 to go from degrees to radians. So if we go from radians to degrees, we're going to do it the other way. So to go from radians to degrees, we'll multiply by 180 over pi, because every 180 degrees is equal to pi radians. So that's what we're going to do here to figure out what pi over 4 is. So pi over 4 times 180 over pi gives us 45 degrees. So this, we're doing the sine of 45. Alright, pi over 6 times 180 over pi. The pi's cancel out. 180 over 6 equals 30 degrees. Alright, pi over 3. Multiply that by 180 over pi. That converts to 60 degrees. Alright, so we're just doing the same questions that we did back when we learned about right triangles, but now it's one extra step. The angles are in radians. So we did that first step. We converted all these to degrees. So now we're doing the sine of 45, the cosine of 30, and the tangent of 60. So to do that, we need some triangles. So for the first one, I'll do a 45, 45, 90 triangle. All right, and I'll make the legs 1. I know they're equal because it's isosceles, and then the hypotenuse would have to be the square root of 2 because you know, Pythagorean theorem. So that means the sine of 45. Pick either of these angles. I'm going to do opposite over hypotenuse. So I get 1 over root 2. Alright, and if you rationalize that, you get root 2 over 2. So that's the answer to 8, root 2 over 2. That's the best answer you could give. Alright, for the other two, we're going to do 30, 60, 90 triangles. So that angle's 30 and that angle's 60. Alright, I can make any of these sides any length that I want. So I'm going to make my life easy. I'm going to make that side 1, the shortest side. Which means the hypotenuse is going to be double that, because that's always the ratio between the short leg and the hypotenuse of a 30, 60, 90. Alright, remember that has to do with a 30, 60, 90 is like a half of an equilateral triangle. Alright, so that side's 2, that side's 2, and that side's 2, because all the angles are 60. When you split it in half, alright, you get this side gets split in half. And then if you do the Pythagorean theorem, or you know your ratios, then you know that this side is root 3. So for the cosine of 30, I'm going to use this angle, and then I'm going to do adjacent over hypotenuse. So I get root 3 over 2. And then for the tangent of 60, I'll use this angle, and I'm going to do opposite over adjacent. So I get root 3 over 1, which is just root 3.